Hi, sixth graders. Today we are working in Chapter 3, Lesson 1. We are learning how to add and subtract decimals. We are looking at our Learning Standard 6 in the number system, Substandard 3. We're looking at fluently adding, subtracting, multiplying, and dividing multi-digit decimals using the standard algorithm for each operation. And today we're focusing on adding and subtracting. So we are going to start off with an example from the sports world. Swimming. One event in competitive swimming is the women's 100-meter butterfly. The table shows the times of different swimmers at a recent Olympics. So then we have a table here, 3 different swimmers and their respective times. Okay, and we'll notice that there is one time that is missing. We are going to figure that out from our word problems below. So we can use place value charts to compare the results. Okay, so remember we're missing the time for Christine Magnuson. So it says that it took Christine Magnuson 0.37 seconds longer to finish than Elizabeth Trickett. What was Magnuson's time in seconds? Okay, so remember in swimming, the person with the smallest number for their time, in other words, the fastest person, the person who took the least amount of time, is the winner. Okay, so Christine Magnuson took 0.37 seconds, or 37 hundredths of a second longer. So what was Christine Magnuson's time in seconds? So here we have, we take Elizabeth Trickett's time, 56.73 seconds, and then we add on to that the 0.37 seconds because that's how much longer it took Christine. So we add these together. When we're adding decimals, we want to make sure that we're adding the correct place values together. So we can only add the ones place to other ones places. We can only add the tens place to other tens places. And we can only add hundreds to hundreds. So I can only add, if you're thinking of it as money, I can only add, the ones place of money. So $1 plus $5 would be $6. I can't say add 100 and a 1 in the same place value in our columns. So we always line up our decimals. So we only add tenths with tenths. We only add hundredths with hundredths. So we do that here. You can see that the decimals are all lined up. When we are adding and subtracting, we will work from the right to the left, okay? In case we need to carry or borrow. We're adding in this instance, so 3 plus 7 is 10. We write the 0 and carry the 1. 7 plus 3 is 10, plus the 1 we carried is 11. So we write the 1, carry the 1. 1 plus 6 is 7, plus 0. So 1 plus 6 plus 0 is 7. And 5 plus nothing is 5. So 57.1 seconds is how long it took Christine Magnuson. So I'm just going to write that in here. 57.10. And then we're going to go ahead and leave that 0 in there because it lets us know that it's very precise, so that we know that we didn't round to that 0.1. It was actually 57.10. Next, at a high school swim meet, a swimmer swam the women's 100-meter butterfly in 72.34 seconds. How many seconds faster did Gabriela Silva swim her race? Okay, so a high schooler swam in 72.34 seconds. Okay, Gabriela Silva, okay, who is an Olympic swimmer, she's swimming faster than this high school student. She swam the event in 58.10 seconds. So we want to know how much faster she was. So we want to know what the difference is. The difference. What's the difference between the two swimmers? And remember, difference in math is subtraction. Okay, so we'll be subtracting the high school student's time, 72.34 seconds, minus Gabriela Silva's time, 58.10 seconds. And again, we notice we have our decimals lined up. Line up the decimals. So this is subtraction. 4 minus 0 is 4. 3 minus 1 is 2. Okay, we can't do 2 minus 8, so we need to borrow. So we go right over here next door to the tens, and we're going to regroup or borrow. So we're going to borrow a 10 from here. This becomes a 6. All right, and the a single from the tens column is 10 in the ones column, so we add a 10 here. So this is now 12, and then 12 minus 8 is 4, and then 6 minus 5 is 1. So the difference is 14.24 seconds. So it took her 14.24 seconds longer. I'm going to go ahead and add in my label here. Okay, and let's talk about our mathematical practices. We're persevering with problems for sure. We had to figure out what was the missing piece of data, Christine Magnuson. We didn't really have to reason abstractly, construct an argument. We didn't really need to model. This was all set up for us. We did not use any math tools. We didn't use any calculators. We did attend to precision. We made sure that our decimal places were lined up correctly. We did make use of structure. Again, our ones places are lined up together, our tens places are lined up together, and so on. And we didn't really have to do a whole lot of reasoning here. This was a pretty straightforward algorithm. Okay, so those are our standards for mathematical practices. Let's go ahead and turn the page to 178. All right, so we are going to look at adding decimals. First, let's talk about accuracy. It's really important to be accurate when we're working with math. To find an accurate sum or difference, line up the digits based on their place values. Use the decimal point to help align the correct digits before completing the operation. So we always need to line up our decimal. That helps us to make sure that we're keeping our place values in the correct place, and we are keeping like terms, like the ones places with the ones places. So to add decimals, line up the decimal points, then add digits in the same place value position. So example, and I know this is all worked out for it here, but I'm going to worked out for us here, but I'm going to go ahead and work through the problem with you. So we have 23.1 and we're adding 5.8. Sum is a mathematical term. It means it's the answer to an addition problem. So anytime we see the word sum, we're going to add. So we have the sum, we are being asked to find the sum of 23.1 and 5.8. Line up the decimals. Say it with me. Line up the decimals. 1 plus 8 is 9. 5 plus 3 is 8. 2 plus nothing is 2. So our answer is 28.9, and we box our answer. Number 2. Find the sum of 29.6 and 14.7. This is a little crooked. Okay, so 29.6 plus 14.7. Line up the decimals. Okay, 6 plus 7, well, 6 plus 6 is 12, so 6 plus 7 is 1 more, 13. We write the 3 and carry the 1. 9 plus 1 is 10, plus 4 is 14. Write the 4, carry the 1. 2 plus 1 is 3, plus 1 is 4. So 44.3. Okay, let's talk about this check for reasonableness, because in math, sometimes we just get right to that algorithm and we do that number straight through, and sometimes we don't check to see if our answer is reasonable. So now we're going to do these parts that are in red. So we're going to estimate 29.6, I'm going to round that to 30. 14.7, I'm going to round that to 15. 30 plus 15 is 45. Okay, so we want to check for reasonableness now. My answer was 44.3. Is that approximately equal to 45? Yes, it is. So we always want to check for reasonableness, and then in the beginning of the year, our textbook will kind of scaffold this, and it'll have this written in for us to remind us to do it. But as we get a little bit farther along in our math program at the end of 6th grade and then throughout 7th and 8th grade, there will be fewer reminders of you to check for reasonableness. So make sure we get into that good habit while we're in 6th grade. All right, and let's do some practice problems together. Got it? We have 54.7. And I'm going to be really careful to line up my decimals here. Plus 21.4. Line up the decimals. 7 plus 4 is 11. Write the 1, carry the 1. 4 plus 1 is 5, plus 1 is 6, and 5 plus 2 is 7. So we get 76.1. Letter B, we have 14.2 plus 23.5, so I'm going to write that vertically, 14.2 plus 23.5. I'm going to line up my decimals. 2 plus 5 is 7, 4 plus 3 is 7, 1 plus 2 is 3. And got it, C? 17.3 plus 33.5. Line up the decimals. 5 plus 3 is 8. 7 plus 3 is 10. Write the 0, carry the 1. 3 plus 1 plus 1 is 5. So we have 50.8. Letter B was 37.7. All right. So then we're going to go ahead and move on to subtracting decimals on page 179. To subtract decimals, line up the decimal points, then subtract the digits in the same place value position. You may need to annex or place zeros at the end of a decimal in order to subtract. So if I need to subtract 3 from something and then I look up and there isn't a number above that, I'll need to place a 0 there or in any other place values that I need to subtract from. And then I'll need to borrow from farther over so that I can have a 10 there. All right, so we'll do an example with an annexing of zeros required. All right, so let's look at example 3. We have 5. Well, let's read it first. Find the difference of 5.774, 5 and 774 thousandths, and 2.371, 2 and 371 thousandths. So we're going to go ahead and subtract 5.774 minus 2.371. Line up the decimals. Say it with me. Line up the decimals. So then we always work from right to left. 4 minus 1 is 3. 7 minus 7 is 0. 7 minus 3 is 4. And 5 minus 2 is 3. So we have 3.403 and we box our answer. All right, so now number 4, we get to practice annexing zeros. So we have 6 minus 4.78. Okay, so we'll notice there aren't as many. This has 0 numbers after the decimal, and this number has 2 numbers after the decimal. So when I try to line this up, 6 minus 4.78, I will notice, well, that's my whole number. I lined it up with the whole number, 6 and 4. But when I need to subtract the 8, there's nothing above it. So I need to annex or place zeros here. So line up the decimals, okay? Decimal, decimal, decimal. And then I'll annex zeros here, okay? Because I can write the 6 as 6.00 in order to be able to subtract. Okay, I can't do 0 minus 8, and I can't do 0 minus 7. So I'm going to come over here to the 6, and I'm going to borrow. That's going to become a 5, which makes this a 10. But I know I need to borrow from that over here. So I'm going to borrow from my 10. Now my 10 becomes a 9. Sorry, I made my slashes different ways. And then this is now a 10. So 10 minus 8 is 2. 9 minus 7 is 2. And 5 minus 4 is 1. So I have 1.22. Okay, let's do another example where we need to annex zeros. Find 23 minus 4.216. So 23 minus 4.216. So I don't have any zeros after the 23. I will need to annex those zeros here. Okay, I can't subtract here or here or here, and then I can't even borrow from the 3 because 3 minus 4 won't work either. So I need to come over here to this 2 to borrow. So the 2 is going to become a 1, which lets this 3 become a 13, but then I'm going to borrow from the 13 and make it a 12, so this can become a 10, and then I'll borrow from this 10, it becomes a 9, so this can become a 10, and I borrow from this 10, it becomes a 9, so this can become a 10. Okay, so lots of regrouping here. 10 minus 6 is 4. 9 minus 1 is 8. 9 minus 2 is 7. We lined up our decimals. 12 minus 4 is 8. And 1 minus nothing is 1. So we get 18.784. 18 and 784 thousandths. Okay, find each difference. We're going to do some examples off to the side. There's not a whole lot of room to work here, so I'm just going to copy this problem over to my workspace. So I'm not going to try to squish it in at the bottom there. So I'm just copying this problem down. D was 9.543 minus 3.67, and I'm not squishing these numbers together because I want to make sure that I have room. Some numbers are thinner than the others. So line up our decimals. 3 minus 1 is 2. I can't do 4 minus 7, and I look over here. If I borrow from the 5, that's not going to be enough to subtract here, so I'm going to go ahead and go all the way over to the 9. So the 9 becomes an 8, okay, which lets this 5 becomes a 15. Then I borrow from that, it becomes a 14, which makes this a 14. So I have 14 minus 7, which is 7, 14 minus 6, which is 8, and 8 minus 3, which is 5. So I have 5.872, 5 and 872 thousandths. I'm going to go ahead and write that down here. 5.872. And then I'll do got it E up here. We have $50.62 minus $39.81. Line up our decimals. 2 minus 1 is 1. I can't do 6 minus 8, and then I look over here. This won't be big enough to borrow from, so then I'm going to go all the way over to my 5. The 5 becomes a 4, so that this 0 can become a 10, and then I'll borrow from that 10, making it a 9, so that this 6 can become a 16. 16 minus 8 is 8. 9 minus 9 is 0. 4 minus 3 is 1. So we have $10.81. I'm going to write that at the bottom. $10.81. Okay, got it F. We have 14 minus 9.09, and remember we always want to line up the ones places together. Decimals get lined up. So here is where my decimal belongs. I need to subtract the 9 cents or the 9/100ths, so I need to annex zeros here. Because I can't do 0 minus 9, I need to borrow from here. So we have, I can't borrow. That's not big enough to borrow from either, so I'm going to go over here. And some of you just do the 14 minus 9. That's fine. Because you might think of it like instead of as a 1 and a 4, you might be thinking of it like as 13. So you could just go ahead and change that to 13. And if your parents or your 5th grade teacher taught you to do it that way, that's awesome. That's a good way to do it too. Okay, I like to keep those columns straight because then it's just that same consistency no matter what the digits are we're working with. So then that's a 14, and I borrow from that, and it becomes a 13. And that makes this a 10, and I borrow from that, and it makes it a 9, and that makes this a 10. Line up the decimals. 10 minus 9 is 1. 9 minus 0 is 9. And 13 minus 9 is 4. So we have 4.91. So we're going to check for reasonableness on all of these problems because we want to make sure our answers make sense. Okay, so I'm just going to, let's see if I get my camera down there. Check for reasonableness. I'm going to estimate this to be 10 minus 4. 10 minus 4 would be 6. This is pretty close to 6. Okay, so my answer is reasonable. Then I'm going to check for reasonableness here. 50 approximately. This is approximately 40. 50 minus 40 would be 10. My answer is pretty close to 10. Okay, and then 14, I'm going to round that to 15 minus 10. Yeah, okay, 5, that's pretty close to 5. Okay, so I just check for reasonableness, and then honestly, I don't typically write that down as I'm doing it, but in 6th grade we do because we're still building that habit. So when you're an adult, you won't be doing that on written paper, you'll just be kind of thinking of that in your mind. Okay, let's turn the page to 180. Reagan is creating a video. The first video clip was 22.36 minutes long, and the second video clip was 17.03 minutes long. What is the total length of the video? Okay, so our work is already done here for us. So we have 22.36 plus 17.03. They estimated that to 22 plus 17, which is 39. Great. Actually, over here, I'm going to go back just for a second. I should have rounded this. I was just kind of really rounding. I should have rounded this to 9. Okay. And kept this at 14 because it's a whole number. So it could be when we're working with larger numbers, we could round those to the nearest, 5 or 10. But when we're working with decimals, we really want to round to the nearest whole number. So I just want to correct that right there. So that would be 14 minus 9. Okay. And that still gives us a reasonable answer, 4.91. All right, back to this. We have our decimals are lined up. Let's get the camera in the right spot. Six plus 3 is 9. 3 plus 0 is 3. 2 plus 7 is 9. 2 plus 1 is 3. So 39.39. All right, so that's just an example. Now let's look at Jonathan. Jonathan is traveling for work. This morning, his GPS indicated that his total distance to his destination is 589.4 miles. Before lunch, he drove 208.62 miles. How much farther does Jonathan need to travel? Okay, so the total distance, 589.4, minus how far he's already gone, 208.62, will give us the amount that he still needs to travel. So that's going to be a subtraction problem. I'm just going to work right here so I have some extra space or some blank space to work in. 589.4 minus 208.62. Okay, line up the decimals. And we don't have anything above the 2 to subtract here, so we're going to annex a 0. We can't do 0 minus 2, so we need to borrow. 4 minus 6, that 4 is already not big enough, so we're going to borrow from the 9. This 9 becomes an 8, which makes that 4 a 14, and I can borrow from that to make it a 13, and this is a 10. So 10 minus 2 is 8. 13 minus 6 is 7. 8 minus 8 is 0. 8 minus 0 is 8. 5 minus 2 is 3. So 380.78 miles is how much he has left to drive. 380.78 miles. And I should have written our units here as well. Okay, so let's go ahead and I want you to try the guided practice right now on your own, and then we will go over those questions together. Guided practice, find each sum or difference. So number 1, we have 14.7 plus 87.9. So 14.7 plus 87.9. Okay, line up the decimals. 7 plus 9 is 16. We write the 6, carry the 1. 7 plus 4 is 11, plus 1 is 12. Write the 2, carry the 1. 8 plus 1 plus 1 is 10. So we have 102.6. Number 2, 66.5 minus 24.1. Okay, so we would write 66.5 minus 24.1 vertically, making sure that we line up our decimals. Line up the decimals. 5 minus 1 is 4. 6 minus 4 is 2, and 6 minus 2 is 4. Okay, number 3, 52.1 minus 31.4. 52.1 minus 31.47. Excuse me, I didn't say the 7 a moment ago. And then we'll annex a 0 here. I can't do 0 minus 7. I can't do 1 minus 4. So I'm going to come over here to this 2 to borrow. So this 2 becomes a 1, which makes this 1 into an 11. I'm going to borrow from that, making it a 10 to make this a 10. 10 line up our decimals. 10 minus 7 is 3. 10 minus 4 is 6. 1 minus 1 is 0. And 5 minus 3 is 2. So we have 20.63. And that's a little sloppy. I'm just going to rewrite that. 20.63. All right, number 4. Grayson is making a snack mix for his family camping trip. He added 14.52 ounces of peanuts to 27.35 ounces of granola. How many ounces of snack mix does he have? So we have 14.52 plus 27.35. Line up your decimals. 2 plus 5 is 7. 5 plus 3 is 8. 4 plus 7 is 11. Write the 1, carry the 1. 2 plus 1 plus 1 is 4. So 41.87 ounces. And then number 5, building on the essential question, how is estimation helpful when adding and subtracting decimals? It really lets us know if our answer is reasonable. All right, so we know if we made a mistake with our arithmetic. It helps us to know if our answer is reasonable. Okay, and then tonight for homework, you will have some independent practice on adding and subtracting decimals on your own. Thank you.